Hello everyone, I'm Shorab. Today I'll be showing you an interesting project. I've done it a few days ago. It was on street light or street signal, whatever you can say. It's quite easy, but there's something you have to know first to do this project. Actually, I'm not gonna show you how to connect these things and just make it work. I'm actually give you something. Uh, by that, you'll know actually what the hell you're doing. Uh, anyways, uh, okay. You might wondering. Uh, I'm a student of Tripoli, of course. I'm studying in AIB, and I'm in 8th semester right now. You might ask yourself, what is traffic light? Advantages of traffic light, how traffic signal works. Okay, in this picture you can see that route 8 and route 4 drivers are stopping because they're seeing the red light. On the other hand, route 2 and route 6 users will go through route 1 and route 5. They can also go to route 7 and route 3 because they're seeing green light. On the next step, as you can see, the route 8 and 4 driver, now they will see the yellow sign. For that they will get ready, or they will start their engine, whatever they want to. I mean, they have to be conscious because they have to pass through. On the other hand, route 2 and route 6 drivers will stop their vehicle because on that time they will see the red signal. And there are some stupid drivers, like while they see the red light, they try to cross in hurry so that they can go to their destination. Anyways, for that, basically this YOLO signal is, because when 8 and 4 users will see the YOLO signal, they will get ready but not start their vehicle, because there might be some stupid drivers still going on from 2 to 5 or 6 to 1. Anyways, on the next step, as you can see, I'm sorry, here, now the route 8 and 4 users will see green light, so they can pass easily through route 1 and route 3 and route 7 to route 5. But the drivers of route 2 and 6, they'll see the red light and they'll stop. To basically get it right, it's easy and simple. Anyways, let's get okay. Now I'll talk about some components. uh, there's not that much of components, but uh, you need to be careful while you choose what components to use, because there are a lot of numbers and variations in ICs. There might be different pins or connector, so you have to nitpicky on that. Anyways, so we will need IC, of course, one timer IC, and decade counter. This is also called BCD counter. It counts from 0 to 9 uh, uh, with a given time pulse. Okay, and this is the timer IC. It's rated, it's named as 555. Okay, those are two IC we will need. And then we'll need LEDs. We need 4 green LEDs, 4 yellow LEDs, and 4 red LEDs, and we need 1 extra red LED. You might need, you can use 1 blue LED or any other color LED if you want to, but here I will use 1 red LED, 1 extra red LED, that one. Okay. Okay, resistors, we will use 4.70 kilo ohm, 1 resistor, and 330 ohm. We need 2, and potentiometer. It's also called the pot resistor. You can vary that. It's also called the variable resistor. You know that. You should know that. Okay, diode. We need 1N4007. I don't know why I need it, but just for this specific purpose, I found it more reliable, so I'm using it. Anyways, for capacitor, I'm using 100 microfarad, one capacitor, and 10 microfarad. Battery, you can use 9-volt battery, you can use only one, but I'm here for this experiment or this project I'm using two. Breadboard, small size, two. You can actually, there's something, if you want to plot everything very close, you may use one breadboard, but I wanted to make uh, this more what can I say, like I want to make it look beautiful or look clean, so I use two breadboard. Connecting wires, male to male, I need 42 wires for this project. uh, you might need more or less than that. It all depends on you. I'm sorry. So on the next step, okay, let's talk about timer IC. uh, Here the definition of timer IC, you can pause the video and read. By the way, on the time, those are the pin, as you can see, this is the serial number. Okay, let's talk about the pins. Number one, the pin number one, where we will start counting from the left side. 1 2 3 4. This is the, now these are the numbers are denoted here. The point one is for ground, and two we'll be shorting this trigger and threshold, as you will see on the next step. By the way, so let's get through the pins. Number 2 is trigger, number 3 is output, 4 is reset, 5 is control voltage. You can control voltage by this pin, and there's something called threshold. Pin 7 is discharge, and 8 is power supply, VCC. Okay, now we can vary the time delay. I mean, as it generates the clock pulse, so we can vary that in which specific time delay it will make the pulse go up and down. On the next step, we will see that the decade counter is called the BCD counter, as said earlier. Okay, here's a lot of pins. We will be shorting the reset, enable, and ground. Um, why, I will tell you later. And the carry out will be open circuit. It will be open. This is the count. It will count from 0 1 2 3 4 5 6 7 8 9. Okay. This is the IC. You can see 4017 BE. Okay, you know what decade counter do? It actually counts from 0 to 9. We can use this counter in many purpose, because as you can, if you watch the truth table, you can see that we use some steps. Like if we break down this IC, we will see there are some small JK flip-flops. It's quite interesting. I don't want to talk about that because it will be this video will be too long. But you know what? If you want, I can explain that, but for the sake of this video, I will not do it, because you'll get bored. I don't know, you already get bored maybe. By the way, on the next step, the connection, we need to be careful, because if anywhere just left open, the whole circuit may not work. So we need to be careful on that. Anyways, the circuit diagrams here, okay, concentrate here. This is the timer IC, okay, and this is the decade counter. Look at the connections. This is the 4.7 kilo ohm resistor, and this is the variable power resistor or the potentiometer. We've used two diodes here because we wanted to make the flow more constant. you can make it open. You don't have to use diode here. uh, you can open this port and you can short this. Okay, and here, as you can see, I told before that threshold and trigger will be shorted. As you can see, 6 and 2 are shorted, and they are connected to the variable resistor. Okay, see that? And the discharge pin is directly connected between the resistor 2 and resistor 1 here, this way. And then the resistor 1 will connect it directly to VCC from the battery, of course. Yeah, the positive side of battery. And then we are shorted the reset to the VCC. We have just connected it directly here. Okay, on the next part, we also connected a capacitor 100 microfarad to the trigger and threshold pin, as you can see. And the ground portion is here. We made it ground, and there's also we have used a capacitor. I mean, I've used, always talking about we because it's a group project, so I used to talk like that. uh, Anyways, okay, sorry for my language. I don't speak in English a lot, but I'm trying to describe as much I can, so forgive me if I can make you understand. Anyways, here's the capacitor. It's connected to pin 5. It's called control. Okay, so this is connected to the pin 5 and the other side is grounded. If you want, you can ignore that. Okay, you don't have to use it if you don't want it, but uh, it's better to have something than nothing. Okay, you can use it. By the way, we have connected VCC to pin 8 and 1 to the ground. That's simple. And we're taking output from the pin number 3. Here's some tricks. I mean, not tricks, like there's an LED here. I'll talk about it later. So here is a decade counter. We're giving clock pulse from the pin 14, and pin 13, 15 and the ground are shorted and connected to the main ground. And we are taking the outputs from these pins. You can check out from the previous diagrams here. You can check it out. Here we will be connected some diodes. Diode 1, 2, 3, 4, 5, 6, 7, 8. And we are look at the wires from pin 3 to diode 1, 2. We left behind 2 pins, pin 10 and pin 11. Okay, we didn't connected this with any kind of diodes. We just left it open. Why? I'll tell you later. Anyways, pin 3, 2, 4, 7, these are shorted. You can see that, like on the diode end. See, these are shorted. And on the other side, pin 1, 5, 6, 9, they are also shorted on the diode end. Okay, so from the diode, we just connected the wire to LEDs. To the LED connection, you can see this is the green LED. This is green, this is green, this is green. The middle one is yellow, 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 and this is red. Okay, this might be confusing for you, but it's quite simple, trust me. Okay, don't look at these wires. Listen what I'm saying. This green LED and this green LED are parallel. Okay, just make this parallel, and the output from these diodes, like this wire, is going to this LED and this LED. As these are parallel, so the power will go directly to this LED, and then from these LEDs output, we are giving the input to these 2 red LEDs. Okay, these 2 red LEDs, and these are also parallel. You can see that these are also parallel. From this red LEDs, we are shorting it to the ground, not shorting it. We are connecting with it one resistor. The resistor value is 330 ohm, and we also connected a LED light parallel with the resistor. This LED actually indicates to give us the indication of the clock pulse it's the timer IC is making. So this LED will blink when it makes every single pulse, so we can see that in which rate this LED is blinking, and we can calculate the time, or we can have an idea about the pulse making of the timer diagram, timer IC. Speaking of the timer IC, let's get back to our previous diagram of timer IC, and let's see. Okay, here is some formulas by which we can vary the time, or we can calculate the time. Okay, as you can see, it's frequency. It's for frequency, and we can find out the frequency by this equation: 1 divided by 0.693 into the capacitor value. This will be the capacitor 1, like the 100 microfarad we have used on our circuit, into the capacitor value, and we will multiply it by the first resistor value, and we will add the value of the second resistor multiplied by 2. Okay, so this is the formula. You check it, and by getting the frequency we will get the time. 1 divided by the frequency, we will get the time, and this time, that's what we need. Okay, let's get back to the diagram and talk about the other thing. These two red LEDs are parallel, and we have taken the input from the green LED's output, and we have connected it with one resistor and connected with ground. And okay, that's it for the first connection, and for the second connection we will do the same for these two, and we will take the second output from these diodes, shorting them and taking the output to these two green LED. These are also parallel, and their output is going to these two red LEDs. These are also parallel, and from this red LED's output we are having this wire and connected it with 330 ohm resistor and shorting it to the ground. How we connect the yellow LEDs? You can see the pin number 10. We will take the wire connected with the yellow. The yellow output is coming to this yellow, and this is going here to the red LED's input. Okay, the green LED's input to the red, and the yellow LED's input to the red. The green LED output is to the red input, and the yellow LED's output is to the red LED's input. And then this 11, this will also come from here, and it will get into the yellow LED's input, and from its output, and another yellow LED's input, and from its output, and it's also connected to the red LED's input. I mean, these two red LED's input, and from their output, as they're same as was before. So yeah, this is all about the connection. Let's talk about how this actually works, why these diodes are connected like that. Okay, when we give a clock pulse, the first is the number 1. This will count, this will be counted, and second this will be counted, and the third clock pulse this will be counted, and the fourth this. So it will count basically 0, 1, 2, 3, 4, 5, 6, 7, 8. For 0 to 3, these 4 diodes are shorted. So for the 4 blinking of this LED, I mean for the 4 clock pulse, these 4 will stay constant, and the green light will be lit for 4 clock pulse. And from this green LED, we are taking the output to the red LED. The red LED also be lit up for that specific 4 pulse. And on the next step, when the 4 pulse will end, then it will come the next one, which is 0, 4, like 0, 1, 2, 3, 4, and it's basically the number 5. And when the 5 will come, then the yellow LED will blink for will lit up actually for specific one pulse only, for one pulse. And on the next step, the yellow light will go off and the next cycle will be started. I mean, not cycle, and the next pulse will come and pin 1 will be activated, like from 06, 05, 06, 07, 08, 09. These are connected here, you can see, and these are also connected to the two green LED, and the next two green LED will blink after this yellow LED turns off. And on the same time these two green LED will light up, and on the same time the other two red LED will be lit up so that the vehicle can go and pass, all that. And on the next step there is the last pin is 11, which is 9, and this is the last count. And this is also you look here that this is also connected with the yellow one, these two yellow. So at last these two yellow will light up and the cycle will repeating itself by time to time. I think you understand. If you don't, try to look through it, you'll get an idea what's going on. So mm, that's it. I mean, let's go, let's see the demonstration. Let's apply all these things to the breadboard, connect it with wires, and let's check out. So these are 330 ohms resistor, these are 4.7 kilo ohm resistor, this is 10 kilo ohm resistor. Let's talk about the connections. This is the timer IC, these are the capacitors, this is diode, this is the pulse indicating LED, and this is the decade counter. These are the diodes connected with the decade counter pin. From these diodes I took the connection to the LEDs. As you can see, I'll be uploading a clear photo of it on the video description. You might check out. Now I will show you how everything works. Okay, let me just turn out the light. It's cool, right?